In today's lesson, we're going to continue to look at patterns to algebra, but we're going to look at comparing two different patterns. So the goal from this is to kind of understand what do the certain rules or the parts of the rule tell us about each pattern, and how can we use that to describe two different patterns or compare them. So looking at our two rules here, we want to come up with a prediction of will the patterns for these two rules be the same or different. Rule 1 is number of tiles equals position number times 2 plus 5. And rule 2 is the number of tiles equals position number times 5 plus 2. So very similar because we're using the same numbers, however we have them in different spots. If you think they will be different, will one pattern grow by more tiles each time? So that's what I want you to think about. And if you can't quite picture that in your head, let's go through and visualize them. All right, so on the top, we're going to do rule 1. We're going to use a white tile as our constant. So we have our 5 tiles there. And we're going to color in 2 to represent our multiplier. So that's position 1 because it's times 2, so we have our multiplier of 2 plus 5. If we repeat that for the next one, we have our constant, we have our multiplier. Let's put it up here just so we can kind of easily see that multiplier. Position 3, same thing, our constant, our multipliers that we had from before, and we're going to add another 2. And I can continue on to position 4, but I think I'll run out of room, so as long as we get the general idea. The other rule, position number times 5 plus 2. So here I'm going to start off with my constant, which is the plus 2. And I'm going to have my multiplier, which is colored in. So here we have 5. So position 1, they do look identical, so maybe they're going to be the same. If we go on to position 2, though, we now start to see that it's a little bit different. And same with position 3. So we can see that they're both increasing. However, hopefully we can see that even though they're the same at position 1, once we get to position 3, or 2 and then even 3, we can see that one is growing larger than the other. Even though visually they might not look like it, we do see that we have more tiles in position 2 and definitely in position 3. So we want to think about, why are the patterns different? Why are the two patterns different? They had the same numbers, right? So think about, why are the patterns different? You can also think about which part of the rule is responsible for how quickly the pattern grows, and which part of the rule is responsible for for the number of tiles that stay the same. Right? So this first part here, that was our multiplier. Right? Our multiplier changes every time, or increases every time. Oops. So our multiplier is responsible for how our pattern grows. We've talked about that previously when we see it increasing every position. What it increases by every position is our multiplier. And the part of the rule that's responsible for them staying the same, well, that's our constant, right? Because our constant doesn't change. Would our conclusions be true for any two pattern rules that switch the multiplier and the constant? So this would be, if we look at this, we can see that when we switch the constant and the multiplier, right, we can see the two examples here. I'll highlight the two similar numbers. And we can see all we did was switch spots. This statement is asking, would it be true that position 1 stays the same, and all the other positions are going to be different if we just switch the multiplier and the constant. And in this case, it would be true because position 1 multiplies by 1. So because it's multiplying by 1, basically it's saying all we're doing is we're adding two numbers together. And when we add the two numbers, it doesn't matter how we add them, right? If I had, say, for example, y equals 4x plus 3 and y equals 3x plus 4, if that x was a 1 in both of them, or position 1, I'd have 4 plus 3 equals 7, and 3 plus 4, which equals 7. So again, it doesn't matter which way we have it. It should still work out because we're multiplying by 1. So what we want to notice from looking at those two patterns is when we switch the constant and the multiplier, each pattern has the same number of tiles in position 1, and the pattern with the bigger multiplier grows faster. So that's what hopefully you can get out of looking at these two rules and visualizing what those patterns look like. So just as a summary, the multiplier controls how fast a linear pattern grows. The larger the multiplier, the faster the pattern grows. So the larger it is, the faster it'll grow. The smaller it is, the slower the pattern grows. So the smaller the multiplier, the slower it grows. And it's also called the rate of change. Because again, we talked about the multiplier being how our pattern changes every position. So we could also call our multiplier the rate of change. The constant in a linear pattern is always the same. So again, we've talked about that before. The constant stays the same. In a table, the constant value is the output number for an input of 0. So if we have to visualize that, again, remember we talked about, say, position number and number of tiles. When the input is 0, whatever the output is or the number of tiles are, that's our constant. And in a tile pattern, the constant value is the part of the pattern that stays the same in each figure. So again, we've recognized that when we've dealt with the visual patterns that we saw before. So again, just kind of a quick lesson, just recognizing the difference between rules, how the multiplier affects it and how the constant can affect it. And again, just a bit of a summary on what those two parts mean in the rules and a little bit of how you can find them. So again, just kind of reviewing a little bit and adding in some more descriptors of our patterns.